So welcome to the second bi-weekly episode of Effect Time. Today we were supposed to be me and Johannes. Unfortunately, Johannes is a little bit under the weather, so you're gonna be stuck with me. And the purpose of this time it's really to begin to look at some of the common patterns faced in Effect.js in writing production code in everyday application. And in order to do that, one very simple thing that we can start to do, and it's going to be an active contribution to one of the open source repositories on the Effect ecosystem, is to, for example, make a wrapper around the Node.js FileSystem API. And that's what we're gonna do. We're gonna do today. It's a good moment because actually we've done a release yesterday. Was quite a long-awaited release, and there's a few breaking changes in things we're gonna look at today. So the first thing that we probably gonna have to do is like fix a little bit of bugs that might come, not bugs, but well, adapt to the changes of yesterday on the Node.js package of the ecosystem. Won't take that much. It's very small. And then we will begin to the development of a file system wrapper. During the development of the file system wrapper, if we have time, I'd like to explore the possibility of using the new stream module that was also shipped yesterday in a quite big release that's based on the latest version of streams from Zio. Now, I have to say that this is by all means not a planned session. And actually, it's a funny thing because Johannes suggested me for the first editions of Effect Time, let's try to have some sort of predictable outcome. Well, the first active coding session that we're going to do doesn't have a predictable outcome because it's based on a release of yesterday night and on a module that up to yesterday was declared experimental. So anything might go wrong, and bear with me if there are bugs we'll try to fix on the fly. In any case, let's keep the discussion ongoing. I'm open to any question at any point in time, any suggestion or anything that you guys want to discuss. Otherwise, I'll begin screen sharing. And this should be the node package. Can everybody see my screen? Can everybody hear me fine? Show a few hands, maybe. Okay, I see something in the chat. All good here. Perfect. So first of all, we are in the node package of the ecosystem that you find on the Effect organization under the node. Well, it's called simply node. This package is a simple wrapper around Node.js that at the moment is really, really tiny. Fundamentally, it has some, well, process is quite an old thing, so don't even look at process, but it's basically linking into the std in IO and std output, but there are far better ways to do this. We have like a port of Zio CLI that we're gonna look at in a different edition of Effect Time next week's. The interesting part on the node package up to now has been the runtime. The runtime is a custom runtime that exposes a function run main. The function run main, it's supposed to be used as a you can guess, to execute the main function on a Node.js application. And why is that interesting? Because it binds onto the process signals. It handles tear down. graceful tear down, and it will print out a very good trace in case you have some error that was not handled during the program execution. That could be any sort of exception, any sort of unplanned error that is raised. And it sounds simple, but if you think what an error might trigger a sequence of things. A sequence of things could be like, I have an unplanned failure, I need to close down the database transactions, I need to close down the database, I need to close down the socket connections, the HTTP server, and anything else. So when you have an error, as a response of that, you might have another 100 errors where things might go wrong at any point in time. When you have something in production and you have traces enabled, these run main, if you have unplanned failures, it's going to render a full code explaining precisely what went through. This is actually an interesting point because in TypeScript, we were forced to use a compiler plugin to do compile time tracing, to add compile time traces to the code. And Zio 2.0 just shipped with a compiler plugin to do basically exactly the same thing as we were doing for a while. They have done it for performance reasons, because tracing using reflection is very expensive in the JVM. And in our case, it wasn't possible to use reflection at all in a JavaScript environment. So we came out to the same conclusion. But anyway, this is the extent that the Node package exists up to today. There is just a little bit of a stream module, which was based on old streams and just wraps the stream readable and stream writable interfaces. We're probably gonna have to, we will probably ignore this given the stream module has changed radically. Anyway, we said the first thing to do is to update the library that was released yesterday. So let me first pull from the repository. Okay. Here. Okay, the version. Great. At some point in time, we're going to have to upgrade to Yarn 3, even it's wildly better. But for the time being, let's just update effect. Should go up to version 46. And version 46 here. Good moment to discuss versioning. Effect, the API hasn't yet been declared stable, 1.0. So up until we have a 1.0 release, you should expect breaking changes on minors and features on patches. When we get to the point of declaring 1.0, any minor change will be backward compatible. But clearly we based our initial scope on Zio 1.0, but before we were ready to be on par with 1.0, Zio 2.0 almost came out, and there are some major changes around how some data types are encoded. And it made more sense to extend a little bit the scope and directly port stuff from Zio 2.0, so we didn't have to port it twice. Anyway, we plan to detach a stable branch in a matter of a month and a half, maybe by end of the year we have it. That's planned, of course. Like anything in open source, it can slip a little bit. In any case, we shouldn't expect any major change. It's most behind the scenes encoding of how the fiber works, a little bit of optimization, and some renames on combinators that are becoming more more user-friendly, I would say. Naming, as you know, is a hard thing, and the Zio ecosystem has done a great job in simplifying names. Clearly, it wasn't like a 1 month operation. So between 1.0 and 2.0, there was a big chunk of renames. Keep in mind, Zio had preserved a stable 1.0 release, so they packed up all the changes in 2.0. And we will roughly be releasing 1.0 stable a month and a half later than the 2.0 of Zio is released. Anyway, we have updated. Let's try build and run the tests. I don't know if something will break because of the breaking changes or not. It shouldn't. Okay, it builds. There's a very good chance also the tests are gonna pass straight away then. Oh, you see that, for example, is an output that you would receive if something goes wrong using the rendering from run main. So this is clearly a planned test because it passes, but this is the type of output you receive. So you see that is the precise error, the point where the error, the computation was supposed to go, and all the traces, the execution trace that goes back and basically tells you the path that the code went through before raising the exception. This is a simple case. You might have that this fiber is forked by a parent, that is forked by another parent, and you get an ancestry tree. Anyway, it seems everything is passing. Fantastic. No breaking changes on the surface of this library. Good. Index.ts. So here, this is a pattern that where you're going to see many times in application development. And it's a case where you have some sort of external API, in this case, the Node.js FileSystem, and you want to expose a wrapper in your code that fundamentally access this external API in a controlled manner, returning well-defined effects that describes what the operations are doing. So let's usually you start with simply importing the library. In this case, it's directly Node. Otherwise, it may come from any external package. And the first thing to do is like begin to explore how the API works. Now, I know already a little bit of how the file system works, so I won't go into too many details on the API discovery. But I think the first thing we would like to expose is something like it's a file system, so something to write to a file and something to read from a file. Let's start very easy and let's model it. So let's see what write file. We have a few variants. There's an async variant, a synchronous variant. Here I always advise to use like async variants. For the second part of today, or like in a next session, if it takes too long, I would like to take a look how to do that in a streaming fashion. I know in Node.js you have a low-level API where you can directly control file handles and just write buffers and read buffers. That would be probably integrated with Stream. So we will go complexify bit by bit. Let's start by trying to copy this write file in an effect fashion. First of all, we see that it has various overloads, but let's take like one that is more precise, which seems to be this one. See, it's callback based. There is a promise version, but my advice is whenever you can, try to avoid using native promises. What's the problem with native promises? You have absolutely no idea about the error type, whether in a callback fashion you at least have the error type, and promises are like the slowest thing you can do in a Node.js environment and in a JavaScript environment. Well, not the slowest. Generators are slower, and if you're using async await, that's based on generators behind the scenes, so even that will be slower than a plain promise. But plain callbacks are the fastest thing in general. The problem with using the callback based API is that, of course, it's terrible to use directly, so you would need some sort of wrapper. But anyway, let's take a look at that. Let's copy the definition. So we have like a function write file. This is the set of parameters, and is it within fs? Yes, fs. Okay, the callback, we don't want to take it from there, but we want to specify it. Options, here we have eventually the error, and if there is an error we have to do something, else we're fine to go. So this is how we would call this API. We know it's asynchronous, and it doesn't seem to return any facility to cancel the operation if it's ongoing. So for cases like that, you have let's import effect first of all. We have a combinator that's called effect async, which will be renamed to simply async, because effect async is like unnecessarily verbose. Here we have 3 type parameters to specify. Let's check the signature for a second. It takes a registered parameter. That parameter is a callback, is a function. It's a closure, sorry. And in that scope, you have a CB function that roughly takes an effect as an input. So this is basically an asynchronous. Within the fiber, when you get to the point of executing this effect, this register function will be triggered, and by triggering that procedure, anything that is inside will get triggered. And here we have our resume function, and that takes now an effect of unknown. TypeScript inference works left to right, which means that if we do anything within the body of this function, TypeScript won't be able to infer these 3 types from whatever is inside. So in constructors of this type, and for example, one that you might be familiar with is the promise constructor, where you have a resolve function and a reject function. If you do it like that, the promise will be a promise of unknown, because again, there's no way of knowing the type here. So in those cases, you have to annotate explicitly. For example, let's make it a promise of a number, and then we see that this resolve function resolves with a number. In our case, we have three types parameter, and one is the environment, the first one. The second is the error channel, the error that our application might raise, and the third one is the output, channel. So in this case, we don't really want any environment. We don't need to access anything external. The error, we know the type of the error. It's a Node.js error number exception, and the output is a void, because we are writing to a file, and that doesn't return anything. So in this case, we see that our resume function now takes an effect of unknown, our correct exception, and a void. So in this case, we have an error, and we can say resume with a failure of error. Otherwise, we resume with a unit. Effect is a value, so you have to return it. Regarding cancellation, rot file option can take an abort signal. Thank you. That's another interesting thing to integrate. I don't know if in the context of a Node.js thing would be smart to do, because abort signal is not yet standard in Node.js. So I'm not sure if I would use it for the library, or we might use it, and you can only use it if you are providing like a polyfill. Takes an abort signal. Or otherwise, how does it work for Node.js? Could I, like, the abort controller, I believe is not yet a standard, but what does the signal have to do? When provided, corresponding abort controller can be used to cancel actions. Abort signal. Does anybody know how the abort signal actually works in Node.js? Is there a way I can trigger it without an abort controller? Is it like an event emitter or some sort of things like that? Let me check it on Google. Abort signal. Event listener. Okay, it's done with event listeners. So ideally, we can make a small polyfill even internally. definitely a good thing for eventually another session. Okay, this is done, and we can see that now our function returns like the proper type. Now here the first thing that we usually want to do is, like, this is sort of an external exception, and those are not usually tagged objects, not easy to recognize, and we are going to be dealing with unions of errors. So usually a good way to expose that is via tagged objects. So let's build a tagged object for that error case. Extends tagged. We have a case module which is expose a tagged utility to create tagged objects. Read only error Node.js, and we want our thing to return the proper error. So here we will like just create the exception specifying the error. So that's already something. We have our function. We could use it like, let's use this function in a program. Pipe write file. Let's say I want to write a local file, log.txt. I want hello world, and I want to specify some options like mode. Is it, or is it flags? Flags dot a should be append or stuff like that. Another good point that for the future would be to improve and expose a more like refined API where you have like append to file that behind the scenes uses this lower level thing, because clearly here we are borrowing types from Node.js, and you see they are not usually the best. So anyway, that's a low level facility for now. Fonts name, say this is our main program. You see it might trigger an exception of that type. Let's use run main on it from the runtime, and let's chain it to like a positive message. Succeed with if we have completed wrote to file. That should work. Let's see if I have demo environment on. Do I even have it? Yes, Node. No, I don't have demo configured. Let me have a look if I have it in core. No, well, let's make it dev. Yes, Node minus compile. Actually, I have it in a different place. Build.cjs. So we are using the build config, the compiler. We use the TypeScript, which enables compiler plugins. We don't really care about the warnings, neither on the ESM, and we run FileSystem/index. This is just to run it locally and see if it works. And of course it doesn't. Why it doesn't work? It's common JS output, so it should. Okay, that's strange. Yes, no. Cannot find module. Why is it complaining?
I think you have 3 files, tsconfig.json, and then there's 2
Yeah,
tsconfig builds.
CJS missing. Okay. It doesn't seem to like wait or log anything. What's no, it doesn't log anything at all. Because I'm obviously not supposed to do this type of stuff in a library. Yeah. Now, why this is not? It's not complaining, but it's neither. Okay, that's awkward. Let's use the jest. Let's do things in the same way that we are supposed to in a library. Okay. Test. file system fs.test.ts. Describe the FS suite. It writes a file. Oh, did it load a file by any chance? No, it doesn't. It doesn't seem like it did. No, it did not. It's awkward. It's going to be an asynchronous test. And at the moment, we're just going to write the file. So here we had a program to write a file and a log. So let's say const actually, let's write it like a test would be. And run it to a promise. Await on that. Let's try to like pick a stable file on the file system, and let's do it brutally with a process. Path from path. Let's say that this is our file path. We expect, let's use the plain not module to do the check for now. fs.exists file path. I expect it to be truthy. And if it exists, I also want to clean it up. This is an awful way to write a test. By all means, we should do way better. But at least I want to see if everything works. Test. Okay, the test passed, and so the functionality works, and it was a little bit of a problem on the TS node config, which I'll have to debug. By the way, you have in the effect.ts org, you have a playground link, which is a fully configured module to bootstrap in client app, in client code, user code. This is clearly hooking up into a library and doing things on the fly that we are not even supposed to do. So I don't even know why I expected it to work. Anyway, we have removed the rm scene, and somewhere we should have our log with our hello world. Clearly, we don't want to, like, for a test on this level, at this low library inside the internals of a library, you can even survive with a test of this kind just to assert that this fs.write works. But in your client app or in your code, you don't really want to like write. This is a side effect. To test a side effect, we usually want to test that our program will write a file. You don't really want to write the file. To do that, we need to do something else, which was point 2 of the conversation, which is begin to use the environment parameter and the dependency injection side of Effect.js. So we see that here, when we call the write file function, we take our file system straight away from the external module. So there's basically no way to patch in between except doing monkey patching on the module, and it's definitely not something we want to do. So how do we avoid that? We need to create a service. What is a service? A service is simply an interface. Let's call it FS, for example. You have a service ID that is used to identify the service. And well, let's introduce the service ID slightly later. Anyway, we said we have a function. Let's take the signature of this function precisely as it is, and we want to say that here write file. So this service exposes the functionality to write a file. We could just use this type of definitions, but you usually want your services to be isolated and not colliding with anything else. For this, we have a facility in Effect that is very similar to the Zio one. The first thing is to extend. This is new, the new API. You need to extend the service, and inside service, which is in has, or into service, you have to pass a symbol. This symbol will uniquely identify your service, both at the type level and within the environment. So let's create like the FS symbol. This is plain JavaScript, and in TypeScript, when you assign it to a constant, it will have the type unique symbol that fundamentally maps to, like, if I have even 2 unique symbols with the same name in a different file, they will be considered different. And advice here, if you use AMD modules and things that might end up being duplicated, even ESM modules could end up being duplicated. You wanna use symbol for and use a specific identifier, which could be, for example, Effect.js Node FileSystem FS symbol, just like a convention. And in this way, this interface, now let's take a look at what's inside that. Export declare const x fs. Let's look what's inside fs. There are two things. A write file, it's the function that we know of, and there is a service ID, which is again simply of the type fs symbol. Doing this is precisely equivalent to do this read only service ID of this specific type. We have exactly the same result. Let's use this notation for now. We're going to improve on it a little bit, but that's the idea. The second thing we need to create is a way for us to identify the service uniquely within the environment. This tag helps if you have like two services with exactly the same functions to distinguish between one and the other. But now we have to identify it in the environment. And my advice is to call the tag with exactly the same name as the interface that defines the service. It'll become apparent why a little bit later. But here the idea is then we use a tag of fs. It's not imported. Yeah, it's now here. We don't need service any longer. And in here you have to pass again the symbol. This is a tag of fs. Let's see what's inside a tag. There is an off function that transforms your service to this thing called has fs. Has fs, let's try to do this. Declare const has let's see what's inside has. That doesn't seem to be anything at all. It's because the auto-completion doesn't work with symbols so easily. But if we index on fs symbol, we have our write file function. Why have we done that? If we have 100 services, 100 has can be intersected together without ever colliding. Here I can have, let's say that this is my end environment. This is has fs and has clock, which is something from the internal library. It's called clock ID. I still need to standardize the way I call internal symbols. But you see, there are two different services, like service ID1. This is fs. This is the clock ID. And they both expose totally different functions. So this is has. You almost never, is that roughly equivalent of has in Zio? It is not roughly equivalent. It is precisely the same, with the difference that Zio encodes has via a map behind the scenes, and we use just a structured object. But the idea is exactly 100% the same. The question was, is that roughly equivalent to has in in 0. Let's take a look at what we can do now, and it's gonna become apparent why I call this in the same name, with the same name of fs. Export const. Let's say I want to t.access service m fs, and here I have my fs module that I can call from within the environment. Now, to call things from within the environment, we want to, well, we could call things directly, and we could just straight on go and begin to use that. Let's just see the return type of this. You'll see that the return type of this says that this is an effect that requires an environment that has the file system in it. It might fail for an RNO exception. So this is make it clear that this effect requires a file system to be provided. Obviously, using the service in this way is not nice at all, because you would have to type every time access this from the file system, use that function, and it's extremely verbose. So what do we want to do? We want to create a wrapper function Let's actually do it with a this is going to be called write file from end. We're going to clean up this later on. File data options. With that, you can directly use that one from end. And at this point in time, I have a beautiful error. And it tells me that roughly there is has fs is missing within the environment. So I have to provide a live implementation of what does it mean to write to a file. Let's do that. Let's go on. Let's use a pipe. It's nicer. We write our file, then we say we want to provide a service. We want to provide the fs service, and here we need to specify an implementation. To specify an implementation, we have to use, okay, the service ID, which is our symbol, and a write file function, that is our write file function. Now, if I run it to a promise, you're gonna notice it works. Let's double check the types just to understand what goes on behind the scenes. This is now an effect that doesn't require any specific environment, where before providing, this was an effect that required a specific module to be embedded within the environment. Run promise accepts any effect that required the default environment, which contains a clock and a few other things. A random service, it will have a logger in the future, it will have a console in the future, but roughly speaking, that's the default. This is exactly the same thing. Obviously, let's assert that works in exactly the same way. Let's run the test again. This is gonna create the file and delete the file. So you might say nothing changed, and effectively nothing did change. what have we gained? We can now swap over this with like file, data, options, oh no, sorry, this is actually let's say t.u unit. This isn't gonna do anything at all. Let's make it do something. And what it does, it could like, we could maintain const write ops equal to be an array of file, oh, come on. This is an array of a tuple, of a name tuple of the three. Write ops.push file data. File data options. Now I have not created the file, so I do not expect the file to exist, but I expect that my write-ops to equal, we have a single one, with these three things. Now we haven't proven anything. We haven't tested our library. What we are simulating is how we would test a program in our application. Okay, what's going on? Array of array. Sure, I'm missing one array. So if you have a program that interacts with the file system from within the environment, this is how you could control the tests from, well, how you could write the tests for your program. Could you put the expect into the provided write file? Yes, I could throw a thing here, but usually you want to run the program, collect the stuff, and assert in a single place. This is not even the best way to write the test. What I would do is to write the test using a generator and throw from within the generator. So you have an effect first basis and you don't have to go back and forth from an async await. We are gonna convert this to generators slightly later. I wanna finish onto this onto the has part. Now, from here, we see that we have all of the pieces together that makes a service. Now, it's long, it's verbose, it's awful, and there's a tons of repetition. So what we're gonna do now is to optimize starting from this point in time. So usually, especially in app code, you have one implementation, the live implementation of something, of some service, and you might have test doubles, but you don't usually end up with multiple implementations. I'm saying this because we have been specifying the type manually. We could derive the type from a proper constructor for our service, and the advantage of that is that the types will always be automatically updated. That could be an advantage or a disadvantage, depending on perspectives. But I find that in app code, given the type inference in TypeScript is extremely good, when you update some like an inner level service, errors and everything else propagates back to the point where you are dealing with errors and you're gonna spot things. So anyway, let's see how we can derive this from a service constructor. First of all, let's finish with one thing. How would we provide a live implementation? There's two ways. One way is by using provide service that I've done here. There are variants like provide service M, where your service can be an effect that depends on other things and might fail during creation. But especially if you are within a node environment, what you really want to use are layers to construct dependencies at bootstrap time. So what are layers? Find it inside the layer thing, the layer module. And in the layer module, you have a few functions. Two are gonna be interesting for you most of the time. That's from effect and from managed. From effect and from managed, you can see that they take both a tag. So our FS is a tag, and they return a layer that produces, well, they take the tag, they take an implementation, so a constructor. In this case, it's gonna be a managed constructor. In our simple case, it can easily be from effect or even from pure value. We're gonna start with from effect. And say we want to construct an FS. How do we create the service? Creation of services is a side effect, usually, or you have dependencies and anything else. And in here, we define our function and we return it. Write file, and we're gonna also have to return the service ID. This is FS symbol. Const live FS, export const live FS. Here I'm plugging things together. We're gonna unbundle them shortly, but this is now a layer. How do I use a layer? Instead of saying provide service, let's go back to the point where we were creating effectively a file for the purpose of keeping things simple. So here, provide some layer, and here you pass in the layers. So here it's going to be live FS, and here we only have live FS. But what's the point of layers? Layers are composable, so you can use, for example, +++ to construct two things in parallel. You can use this operator to construct first one thing and use its output to provide to another constructor. This basically allows you to draw precisely the dependency tree of your application in a fully detached manner from your main process. So those are layers. To the point here, we have what is called a service constructor. Usually I call this service constructor make live fs as const. So we have our service creator. This can also become like I don't like so much functions. There are two boilerplate. Let's say you have this export. So it was our live implementation. So you see that we define a symbol, we define the implementation. We need to extract the service. You can use a utility called _a that extracts the a parameter from an effect or a managed or a stream. Type of fs, actually, no, sorry, make live fs. And in this way, we are taking the return type of this constructor, which is a UIO that constructs this service structure, and we are using it to create our tag. And this is already shrinking the boilerplate a little bit. The other noisy part that we can shrink is the creation of these accessors. For standard functions or values and simple things in general, and especially if you don't have generics involved or complex structure, you can auto-generate those. How do you do that? There are some variants of derive things. Derive lifted is one that you can use to derive common stuff. It's going to take 3 parameters. And those 3 parameters are, the first one are the functions. The second one are the constant effects. We have none here in this service. And the third one is any value which is within that service. In this case, we want to extract a function. So in extracting a function, we can now generate this automatically. This is the same signature that we wrote manually, but it's now compacted and generated automatically. Everything in here works exactly in the same thing as it was before. This is fs.write file, but we have like the boilerplate now. It's turning to a point where it's roughly acceptable. An advice here, I have used a simple succeed with to create this service, but in real life you have interdependent services and you have resourceful services. So services that depends on something. For example, you have a database API that requires a database pool. The database pool is a resource, has an opening stage and a closing stage, and things like that. I find it extremely useful to use generators here. So instead of simply using this function, we can use t.gen. Now here it's going to be noisy because we don't have any access. I mean, we don't need any access to anything else. But if we would, let's say that now we have, let's make a export const make live logger we want to make a logger that logs on a file, on a log file. Something simple like that, just to showcase an interdependent service. Said you would use t.gen to do that. Inside t.gen, you can use this yield star on this parameter. Is called an adapter function. It transforms an effect into something that can be yielded in this context. But you can yield an effect, or you can yield even a tag directly. If you look at the signature of that, you can yield a tag, you can yield an option, you can yield an either, or you can yield a full effect. In this case, we said we want to access the file system, so we can yield a tag directly, access write file from here, and return, for example, a log string write file. Let's do something bad. The data is simply the string. The mode, the flags are append, and we return a service ID. We need to create another export const logger symbol. Taking a look at this, it's now a service that requires FS. You might ask, why do we access the file system from here? We could have used, okay, let's ignore this. In a generator, you have to have a minimum of one yield, which is why it complains if I comment out any yield. But let's say that we don't want to do anything. Let's silence it for a second. Write access, write file, I can still use it from the environment, but what would be the signature of that now? It's a constructor that doesn't require anything. So we can to construct this service, we don't need any environment. And the log function requires the file system. This is not optimal. We are leaking implementation details on the service layer. If somebody uses our log function, they don't care that we are logging to a file. We could log to a file, we could send an HTTP request, we could log to the console, we could not log at all. So how do we do that? Instead of exposing, accessing the modules from, let's say this is a log function, when this is called, I'm gonna take the FS from the environment. Instead, I want to take the FS from the environment when I construct my service, and I just want to use it in my implementation. This is why generators in this case are extremely helpful, because they allow you to access directly a tag or yield any. Here you can do anything. Here you can like yield t.succeed with. You can do any effect operation in it. You can consider it like an async await, but an async await that works with more stuff and that keeps track of all the types correctly. So in this case, we went back to our initial case. That was an effect that requires a file system and that produces a new module. This is simulating an interdependency between different services within your application. So you could have the database API dependent on the pool. This simulates that. Let's make export interface logger extends a type of make live logger, and we said we need a tag for that. Of the logger, which will require the logger symbol to be provided. And we want to expose export const live logger, which is a layer from effect. And again, we want to construct a logger using the live logger. This now requires, you see, it's a layer that require the FS to be provided, the file system to be provided, and produces a logger. Let's try to use that logger. T.derive lifted logger. So I have my log function, and let's say that I want to say fs.log hello world. This doesn't work yet because it's gonna tell me that let's see what it's telling me. It's telling me that I am missing the logger symbol, so I have to provide the logger. So let's provide the logger first. fs.logger live logger, and you see that now it compiles. But this is not a great way to expose your dependency trees, your construction trees. And we are still using a sequence of provide functions. What you can do when you have a layer, as we said, it's to pack up the layer. So let's say that here I'm in up code. I want to say export const up dependencies. By the way, layer is getting renamed to depths. It's more intuitive, I believe. Let's say that we said we want the live logger. First of all, if we check the type of this, really only requires the logger. So the fact that the logger uses a file system, it's even internal to this logger. It shouldn't be truly exposed unless you use the file system elsewhere. There's no point in exposing the file system. But this logger has fs. I've said before that layers can be combined. So let's take the live fs, which produces a file system module wrapper from an unknown source, and let's plug it into the live logger. And we see that this is now a layer that doesn't require anything to be provided and produces the combination of both the modules. This can be directly used to provide your dependencies, and it works as expected. But we said that this is now requiring only the logger, so there is again no point in having these up depths produce both. In these cases, you can use another operator, which is without the plus in between, and this is now only providing the logger. This is something that you would expose, like export const file base fs logger fs based logger fs based logger. And I might have a totally different implementation that doesn't log onto the file system, but that uses a console, and it will be exposed with exactly the same signature, and you can consume it in exactly the same way. Okay, it seems this took a little bit longer than initially expected. I've lost a little bit of time in trying to set up TS Node on the fly, but the base concept of wrapping modules of external APIs is this type of work. From the next time, I believe I'm gonna begin to improve the number of functionalities in here. One of the suggestions was to use the abort controller to control interruption. Effects are interruptible. If you want to control interruption, you can return from here, from our register callback, another effect that will be invoked when we need to clean up things. Okay, I'm in the wrong one. Yes, it's in here. And here I could say signal. So actually, let's integrate that now for a second. It's not gonna work because I don't have the polyfills, but the idea is to controller, to have a new abort controller. In the options, controller.signal. Spread may only be created from, okay, what's these options? Buffer encoding. This is where I should improve the API a little bit. Buffer encoding null. So it should be this awfulness. Okay, abortable doesn't exist there. No, but abortable is precisely the one that I don't want. Yeah, that's it. And in here, I can say controller dot abort. And this will interrupt the computation properly. So I think for today, this is a good place to leave it for the code. We have bootstrapped the initial structure on how this module would be created, and from the next time we'll be improving that and connect it using streams. If there is any question, I'll take it gladly. Yeah, there are no other questions in the log. Good. So I think that's today. That was the second episode. I wish everybody a good continuation of the day, and see you next time. Cheers, guys. And by the way, I'm gonna be publishing these in a draft PR to be finished in the next times. I hope that was a little bit helpful in introducing the lower level API of Effect. Have a nice day, everybody. Cheers.